to How to Test This, the podcast designed to help software testers understand risk and adopt new testing solutions with ease and confidence. Your host is Mahamadou, a quality assurance consultant with over 10 years of experience across multiple industries. In each episode, he'll talk to different experts and learn from them about how they test.
Hi, and welcome back to How to Test This. Today, I am excited to welcome Paul Holland. Paul is a true legend in the testing industry. He is the owner of the consulting company Testing Thoughts since 2012. He is a software testing executive with over 30 years of experience leading software quality, test strategy, and enterprise test automation programs. He had many roles such as Senior Director of Test Engineering, Director of Testing, Principal Testing Consultant. He worked in multiple industries, including telecom, banking, insurance, medical, retail, physical security. He is one of the 5 instructors of the RST courses. He is the author. He wrote a chapter of the book, Taking Testing Seriously, and he is also a frequent keynote speaker at global conferences, thinking about Agile Testing Days, Quality Connect Romania, OCST. So thank you, Paul, for being here and open to share your experience.
Thanks for having me. Pleased to be here.
Nice. Okay, in this episode, we'll be talking about test reporting. We'll start with Paul's background and experience. Then we'll define test reporting and understand why it matters. Then we'll talk about common mistakes testers tend to make. After that, we'll discuss practical tips on how to write better reports. And finally, we share steps on how to get started if you're interested in becoming a better communicator. So without further ado, let's get started. Thank you, Paul, for being here. What was your first job in testing, and how did you find out you're going to make a career out of it?
Wow. A long time ago, when I was in university in the 1980s, I got a computer science degree. And the one thing that getting a degree in computer science taught me is that I did not want to be a coder. I realized that I did not enjoy coding, even though I didn't mind coding. I wasn't bad at it. It didn't really turn my crank. So what I ended up getting a job right out of university as a laser printer analyst at Xerox. And I got exposed to customer support and troubleshooting, helping customers, working with large laser printers that print 120, 135 pages a minute. And I really enjoyed the deep dive, the investigation part, the why is this not working for this customer part. Then I took a bit of a detour. I spent 5 years in the Canadian military as a helicopter pilot, but that's a different interview. When I got out of the military, I started to look for a job, and the job that I found was through a friend of mine. He knew that I was getting out of the military and that I was looking for a job, so he mentioned it to a director of engineering at Newbridge, which then got bought by Alcatel, became Alcatel-Lucent, and now is Nokia in the West End of Ottawa. And I got hired by that director to be a software tester. I didn't really know what to expect. I just the guy was looking for somebody who could think, learn, and help them find bugs. So I did that for 3 months on a contract, and then I got hired on full time as a software tester. And then I became the first manager of software testers at Newbridge. And then I spent 17 years there, introduced rapid software testing techniques to my team and to my division. And then I was given, I like to say, the opportunity of leaving Newbridge, or at the time Alcatel-Lucent. They offered me an outrageously good severance package because my division was closing down. And so I took the opportunity and became an independent. And that's when I started Testing Thoughts, my own company. I haven't been working exclusively in my own company since then. I worked for 3.5 years at a company called Metadata. I worked at a company called Dorn Jones, which was a consulting company. I've worked at Saks off Fifth Avenue in retail. Uh, I worked for TD Bank a little bit, and then SGI, Saskatchewan Government Insurance in Canada. I had a 2.5 year contract with them. So I have experience across lots of different industries, and I like trying to improve the way things are done at whatever company I'm at.
Okay. And how did you go from being a tester to becoming a leader, like director, instructor, owner?
So in at Newbridge, I was a tester on a team. I reported to a software development manager who had a software development director, and uh, there was no testing community at all. I didn't even know who the other testers were under my director. I'd been there for a couple of years, and I was in my own little tiny silo with my team. And I knew a couple of other testers, and I knew the people. I talked to them, but I didn't really interact with them in a work level. And I approached my manager and I said, I'd like to get a testing community going so that we can learn from each other and we can essentially get uh, better. And so that was approved. So I started to have weekly meetings, weekly testing meetings. And that only lasted probably about 4 or 5 months before there was a sort of a shuffle and I got promoted to test manager and those people ended up reporting to me. So that's how I started sort of in the leadership role. Was I found an opportunity to uh, increase the testing capacity, the testing knowledge of the testers just by having local meetings. And then that got recognized and I became their manager. When I left Alcatel, I was hired as a senior director at Metadata. Actually, that's not true. When I left Alcatel, I was independent for a year and a half, just owning my own company, mostly teaching rapid software testing. I think I only had one in a year and a half gig that was 3 months long where I was not teaching rapid software testing, but I was essentially acting as a principal consultant. But then I was given the opportunity to go to New York and head up testing for a small consultancy of about 50 people working for it. And I headed up the testing company there with a friend of mine, Keith Klain, who had been an executive vice president at Barclays Bank and is now heading up testing for KPMG testing in the UK. And he was the chief operating officer of this company and brought me in to head up testing. And then from there, I went to senior director at Metadata. So, but I think the main reason I was given those opportunities was I approached testing as a skill, as an art form. It wasn't just here's a requirement, here's a test case that I wrote to test that requirement, and now that test passed, so we're good. I always, since I started, approach testing as an investigation, as a discovery. What is wrong with this product? How can it fail in ways that might be important to our customers or to us as a company? Could this get us on the front page of the New York Times in a bad way? And just trying things, exercising my curiosity, and not just limiting myself to follow these steps and see that the product does what it's supposed to according to a written requirement. And my main complaint against testing for written requirements is that the vast majority of requirements of a piece of software aren't written. They're implicit, they're expected. When I move my mouse to the right, I expect the cursor to move from left to right on the screen. If it doesn't, I don't have a requirement that says it's not supposed to go up and down when I move my mouse left and right. it's just expected. Most of what we need the software to do is just expected. When I click on the next button, it should take me to the next step in the process. It shouldn't take me to another process. Literally yesterday, I was trying to book an appointment and I selected an appointment on Tuesday, and there was a next button. I clicked on the next button and it moved it to the following Tuesday and didn't do anything else on the screen. I didn't notice that the date switched from the 12th to the 19th. So then I clicked on, oh, I have to click on this thing instead. So I clicked on this other non-obvious button, and I ended up making an appointment for a week in the future that I wasn't expecting. And again, that next button, it's in my mind, next means go to the next step. It doesn't mean go to the next week. If it's next week, it should say next week, not just next. Anyway, that's something that's not written down. A lot of the times it's just implicit. And to be a good tester, you need to test implicit and tacit, ones that aren't even, you don't even know about. Or that you can't explain, I guess would be a better definition. That you can't readily explain would be a tacit requirement. But my point is, if you're only testing written requirements, you're only testing a tiny percentage of the product. And so by approaching testing in a holistic, how is this going to impact us and our customers way, it sort of elevated me from the other people that were essentially being given a list of requirements and writing tests and executing those tests. And that is probably what differentiated me.
Okay, thank you. I noticed you've been in the field for decades. What's been the biggest change you've noticed over time?
The biggest change is not so much a change. The biggest recent change is AI, obviously. I'd be foolish to say that isn't the biggest change, but the problem with AI is the same problem as all the other fads, new things. So I started in 1995 as a software tester. Agile came along in the early 2000s and started to sweep its way across. And we were told at the time that everybody does the same job. Everybody's just a team member. There's no dedicated roles. You don't need to be a software tester. You're not a developer. Everybody is just a team member. Anybody can do any role. That's stupid. And actually at the company I was at, Alcatel at the time, when they did the shift, they were telling us that the testers had to become developers or essentially team members so they could do development or testing. And so I said to the senior vice president, I said, so what about hardware engineers? Are they going to become team members as well? And he goes, oh, no, there's a line. And so for some reason in his mind, the line between a hardware developer and a software developer was too big to cross, but the line between a software developer and a tester was non-existent, and they should just be the same person, even though it's a totally different mindset, a totally different approach. It's a different set of skills that you need to be an effective tester versus an effective coder. So it actually annoyed me at the time that the senior VP thought that way. He was in Europe. The Ottawa branch where I was working, our VP was a lot more logical about the approach, and he said, no, we're going to keep people who test on our team. So we had teams that were made up of developers and testers, and they kept their roles. So we had, I don't know, between 4 and 7 developers and 1 or 2 testers on each team. And the testers still met with their test manager and kept their competency developing. So Agile was a change, and it was marketed as it's going to fix everything. The trouble with that was there was people who said that's the one way of doing Agile is to do it this one way. And so that's silly. Also in the early 2000s, we had the shift to outsource everything. You don't need to hire people at expensive North American or European salaries. We can outsource to lower priced areas, and testing became a commodity. And if we give them the test cases, this outsourcing group can execute them, or they can write them if we give them the requirements. We've already talked about how that's not how you need to test. So outsource everything was a big thing in the early 2000s. Then in the early 2010s, it was automate everything. Let's just automate everything. And now it's let's use AI to do everything. And the trouble with all of these trends is they're all not doing what a good tester does. You can't replace a good tester with automation. You can't replace a good tester by outsourcing the testing that they do, and you cannot replace a good tester with AI. All of those tools are tools that can help accentuate the product, accentuate your ability to do testing, but they're not going to replace a human who understands the product, deeply understands the domain it executes in, and can think critically. Every single AI tool that I've seen that says, "Oh, we make your test cases for you. We can essentially do the job." The shit, and excuse my language, and if you want to beep that out, you can, but the absolute utter shit that AI tools come up with, and they say, "Here's a good suite of tests." They're not. It's a total garbage. There's they're shallow. It's like I gave a kindergarten student, "How would you test this?" And they said, "I would do this." And you go, "Great." But there's no deep understanding, there's no modeling, there's no thought, there's no understanding. It's literally just a probability tool compared on what it's learned from its learning data, and it can't think, it can't extrapolate new information. All it can do is, with a mathematical probability, say, here's some things that might work. And then the time spent by an individual tester to go through all of those things to see what's right, what's wrong, what's crap, what's good, is far more exhausting and time consuming than just coming up with it yourself. And yeah, occasionally AI is going to say, "Hey, did you think about this?" And you say, "I did not. Now that you've mentioned it, I can think about that. That's a good idea," which is how, in my opinion, AI should be used. But having it develop tests for you, it's a negative gain, in my opinion.
I think you perfectly summarize all the different trends we experience over the last years, and it's important to know so we can understand also what's coming up in the future. And now that we talk about your background, let's talk about the topic of today, which is test reporting. First of all, can you define what is test reporting, its main goal, and why it's
Sure.
important to take it seriously?
Sure. So test report. So before I talk about test reporting, in my opinion, the main goal of a tester is to provide actionable information to stakeholders on the status of the product. So if you aren't providing actionable information on the status of the product to your stakeholders, what the hell are you doing? Why are you even there? If you're checking boxes or saying everything's green, that's not necessarily actionable information. It just means that the shallow automation that you execute every time there's a check-in hasn't detected any deep bugs. Okay, great. So that doesn't mean that the product is ready to go. So what test reporting entails is providing the information on the status of the product. So one, you need to get the information of the status of the product by testing it as well as you can in the time you're given. And then you need to inform the stakeholders what you discovered or what you haven't discovered. What you didn't have time to do or didn't have the capacity of doing is likely as important as what you did cover. And so test reporting is the providing of information in a manner that executives can say, "I understand what's happened, what hasn't happened, and what the outstanding defects are that we're aware of. I think we can ship, or I think we should delay the shipping." And that's, to me, what test reporting is to provide actionable information.
And what's the most common misconception you've heard about test reporting?
That giving numbers like, how many tests did you execute? What was the pass rate? What was our mean time in between defects? What was all of these garbage numbers that literally don't mean anything. If you look at this, so I wrote the chapter in the book, Taking Testing Seriously, which was released November 2025. I wrote chapter 9, which is a book on test reporting without pretentious metrics. And the problem with most test reporting is they rely exclusively on metrics that don't mean anything. And in that chapter, I gave an example based on my own experience where one project had 10,000 tests and a 99% pass rate, and another project had 100 tests, and in actual real life it had 8 tests, and had a low pass rate. I think it was about 50%. And but it doesn't really matter with 8% or with 8 tests. Every one test that fails, you're losing at 12% of your pass rate. But the in my actual situation, the people who used to execute these 10,000 tests and the new group that came along with 8 tests had a meeting because they were concerned. The people with the 10,000 tests were handing over the product essentially to a different division within the company, and the people who had the 8 tests essentially had better test coverage in those 8 tests than the 10,000 tests did. And everybody agreed with that. When they looked at what the 10,000 tests were, they weren't 10,000 tests. They were 10,000 automated steps, like enter the username, pass. That was one step. Enter the password, click login, make sure you are logged in. That was like 4 tests, or it might have only been 2 tests, but it was an insanely minuscule amount of coverage. Meanwhile, the 8 tests, each one took multiple days to run because it was an end-to-end. This system has been delivered to a customer, it gets configured, and data flows and soaks for a certain amount of time. So the problem with metrics is each of those tests I've logged in successfully using automation, or I've done an end-to-end setup and passed data, are each one test, and they each count as one. So how can I compare a very simple 2-second tests to a 2-day test and just say they're each one day? It makes and they're each one test. So if I have 100 tests or 10,000 tests, which one has better test coverage? I have no idea. It's just a number. It's like asking somebody, James Bach uses this as an example, how many briefcases get carried into that building every day? That would tell you how good the building is, or the companies in the building. It makes no difference at all how many briefcases, like what's in the briefcases. That's could be important. So anyway, the biggest mistake people make is they rely on metrics, and there are incredibly few metrics that mean anything as far as providing actionable information on test reporting.
Okay. And you also mentioned executive. Are they the most important persons for whom we have to report to? And why? What are they looking for?
The stakeholders are the most important people that we're writing our test reports for, or giving a verbal test report to. So the stakeholders could be a product owner, could be a VP, could be a CEO. It depends on the size of your company. At Alcatel, it was a product owner. At another company, it was a senior vice president. At another company, it was probably the CEO. Some people think what they're looking for is the metrics that they've been given by test consultancies and outsourcing agencies for decades. So what executives or stakeholders are looking for should be, what's the status of the product, and what are the issues, what's your test coverage, what did you cover, what didn't you cover, and that should let them decide the status of the product and whether it needs to be delayed or rolled back or re-released or whatever. But the sad thing is, a lot of times what they get is, we executed 500 tests and we had a 98% pass rate. Is that good? I have no idea, but they seem to think it is.
Okay. When also you don't have only executive, but when you have many stakeholders with different interests, for example, the CEO, the PO, the compliance officer. Do you prefer creating one report for anyone, or is it better to send different versions to different person?
That's a very good question. I have not needed to create multiple reports because the reports that I tend to make are fairly easy to digest and not a lot of words. If you're having to follow a template for probably bad, misguided reasons, and your test reports are multiple tens of pages long, then you'll probably need to have a summary of a test report that you can give to executives. My test reports tend to be 7 to 10 PowerPoint slides long. They include a mind map of the product that's color coded to show coverage, a list of bugs that are deemed potential showstoppers or important bugs that we decided that we were going to let pass, and risks that we've addressed, risks we haven't addressed, and an executive summary. That's most of what I think. I went all the way to the next section of this interview where I said what I put in my test reports, but that's honestly for the most part the majority of what I put in. No metrics. I actually try to do test reports with 0 metrics in them.
Now, let's talk about the common mistakes to avoid. For you, what's the most common mistakes you see younger testers make when it comes to reporting?
Besides the obvious of thinking that metrics mean something, I would say the next biggest mistake is putting too much information into the test report. Most people who are stakeholders don't necessarily care too much about the details of exactly how you tested, what data you used, and things like that. Beyond we used a representative anonymized data from our production database. Great, that's a good sentence to put in, but don't go into how you anonymized it and how many hours it took to do that work and why blah blah. Like there's just, you need to keep the test report separate from essentially a discussion you're having with your boss. It's what the test report needs to cover is essentially, what did you test? What was your test coverage? What are the known issues? What did you not cover? And in the opposite order. And then what your risks are, and perhaps like a recommendation or essentially a summary, a status summary.
Okay. Like you said earlier, you don't like reports with 100% test pass, for example, number of tests executed, number of bugs. Those are common indicators. But it seems like you're not a big fan of metrics. Can you explain why?
If people are interested, I have a couple of talks up on YouTube. If you look up Paul Holland and metrics or bad metrics, there's one that's really long. It's a rant. It was the first thing I did in like 2011 or 2012 at a CAST conference, the Conference for the Association of Software Testing. I was filling time in between lightning talks, and I was essentially gathering metrics and telling everybody why they were bad. That became a talk the next year where I talked about elements of what makes a bad metric. And it's comparing things of different sizes as the same. So counting test cases, counting bugs, even counting bugs in severities doesn't mean anything, because I might have a critical or a sub 1 bug that we already know that it's going to be fixed or how to fix it, and it'll be fixed tomorrow. Or I have a critical sub 1 bug that requires a rewrite of the database. Those are not the same. They're both criticals. One is a day's work. One is like probably multiple months. You can't just compare them and call them the same thing. So the first problem with metrics is comparing things of different sizes as the same. So a test case, 5 seconds to 2 days, they can't both be a 1. That doesn't make sense. Comparing effort, that would work. So if you, in every single test that you executed, you said how much effort that test was, and then you only summed up the effort, you could use that as a metric, but I still don't know. Oh, I spent 2 months testing, or the team spent 2-person months testing this versus 3-person weeks. Okay, well, what was your coverage? Like, I don't care how long. If you're all useless and it took you 2 months to get the same coverage that a competent team would get in 2 weeks, the amount of time really doesn't matter that much as well. So anyway, there's that. Things that cause competition between teams, team members or teams themselves. So if you're getting something like the number of bugs raised by a tester, or the number of tests executed by somebody, if I know I'm being measured by the number of something that I do, I'll hit the high number no matter how badly I do it or what bad activities I do. You might come to me and say, hey, I'm stuck, I need your help. And I say, I got to get 2 more tests done today. I can't help you, even though you might be working on something more important. I got to hit my stupid numbers. So that's the second thing, causing competition, unhealthy competition. The third element is ones that are easy to game or to circumvent the desired intention. So if you're looking at a pass rate, I was literally approached by a project manager when my pass rate was at 89%, because back early or late 2000 zeros, 2007, 2008, I was reporting on my pass rate. And I had, according to TL 9001, which is a telecom standard, and I think it's the only regulated industry standard that you have to hit a certain pass rate percentage. You have to be at 95% pass rate, or you need to explain why. And I was at 89%. But the project manager came to me and he said, can you do anything about that? And I said, what do you mean? He said, can you execute more tests to get the percentage pass rate up? And I said, I'm not going to do that. So, but pass rate, you can just game it by just running a whole bunch more tests that you know are going to pass, and you'll hit whatever pass rate. Counting the number of bugs, that's another one that's easy to game. I could just add this bug as a comment to this existing bug, but if I'm being measured on how many bugs I raise, I'm going to raise a new bug that because it's slightly different, even though it may not be. The fourth thing is that if they're giving false information, like a false sense of completeness, things like code coverage. Oh, we're at 100% code coverage. Okay, great. That means that there's at least one test that tests each line of code, at least with one thing that happens somewhere. It doesn't tell me how well I'm testing it. It doesn't tell me that it's testing it even in a meaningful way. It just means that that piece of code got executed at least once with some value somewhere. I don't even know if it was a valid value that it got passed. It could have been something that a customer's never going to do, or something that only a small percentage of customers are going to do. And as soon as you deviate, the code could fail. You need to, like, code coverage is helpful if you're trying to see that you're at a level you thought you were at. Like if you think, I think that we should be at 20 or at 80% code coverage, and you run the tool and your tests and you say, holy crap, we're only at 60%. Okay, you've learned something. You've learned that you're not at the level. Once you hit the level, that metric becomes totally useless. So those are the 4 elements that make up a bad metric. And honestly, it gets rid of almost every single metric that's out there. There's a few that exist, but number of tests, number of bugs, number of open bugs, lab equipment usage, percentage of automated test cases, pass rate, number of test steps, and somebody actually had an actual metric that they were being measured on, number of test steps. Those are all just bad metrics. Code coverage, requirements coverage, a percentage behind plan, those are almost all horrible as well. There's 2 metrics that I have on my list that are green, and one of them is the number of bugs reported from the field. Now, I don't like the number of bugs, but a list of bugs reported from the field, or at least if it's coming from the field, it's a lot harder to game, and it's actual customers phoning up with actual complaints. So that one isn't too bad. But again, I prefer a list of bugs than counting them, because if they're all minors, Does it really matter? I guess it might, but and then the other one is hours between crashes in the field. This was one that we used in telecom. We needed a 99.999% uprate. And so we actually measured how long between our system crashes. But all of the other metrics that I listed, they're all pretty much bad metrics, which is why I started to do test reporting without using metrics.
Yeah. Another question about how we work as a testers, and I think we've all experienced that. My question for you is, how do you handle the fact that you have to provide good news and hide bad news? Like, how do you handle this situation?
I never hide bad news. There's actually this is a true story. When I was working at, I won't say the company. When I was working at one of the companies that I worked for, the test team, knew that there was a problem. We were doing something, a data lake. We were essentially grabbing a whole bunch of data that was slightly anonymized to the point that it couldn't be as linked back to the customer it was providing. But we took our hundreds of customers' data and we put a lot of it, not the proprietary stuff, but we were putting stuff into this data lake, and it wasn't going well. The data lake was not aggregating the information properly. And we were finding bugs all over the place. And we kept reporting that we were finding these bugs. We were finding these bugs. And we would report it. The VP of engineering was sort of blocking it. He was saying, oh, we're going to be fixing this. It's shipping. We won't have any bad bugs. The VP of testing, my boss, was reporting up to the chief operating officer, it's not ready. The VP of engineering is not really giving you the full information. This is the real information. And the COO knew the real situation. We were giving examples, we were giving video demos. Like, there was no way that he didn't know. He was not informing the CEOs. That we had co-CEOs at this company, and he wasn't informing the co-CEOs. And finally, this was like 2 months, he knew that we were not really on track because it was a big project. It was multiple months long. And with 2 weeks before we were supposed to release, and our CEOs had been talking to our customers saying, this is coming, it's going to be great. 2 weeks before we released, the COO told the CEOs that, yeah, we're not ready. We're like at least 2 months behind. And he got fired that day. The COO got fired that day. And when the next day we had a huge all staff, like, where the hell is the COO? Why did he get escorted out of the building yesterday? We had an all staff, and one of the co-CEOs said, and this was one of the sayings that I remember the most out of all sayings executives said, he said, bad news does not get better with age. It's not a fine wine. The sooner that you can let us know of bad news, the more we can act on it and the less bad it is. And that stuck with me. That was over 10 years ago that happened. And it has really stuck with me because it's not my job to decide if the news is so bad that there needs to be a change. My job is to tell you the situation. If the news is bad, I tell you bad news. The news is good, I'll tell you the good news. One thing that I will say, though, don't always just give bad news. Like, I'm not saying lie, I'm not saying make up good news, but if you are working with a team of developers and you're only ever saying, hey, John, your code sucked again, here's 5 bugs for you, John is not going to like you. Like, if you go to John, though, and you say, hey, John, I got your update, you fixed 3 of the 5 bugs, that was pretty good, I'm impressed. Don't sound condescending. That sounded really condescending. But if you compliment them saying, hey, you just gave me this code and I was able to get through to the end on the first try, that's, I was impressed by that. And you can let them know that some things are good, and then you can say, oh, and by the way, I'm about to start to hit it with a sledgehammer, so it may not hold up, but the first pass, everything looked good. That that's a good information to give John, so that he's not thinking that you're just the bearer of bad news and, oh God, here comes Paul. He's going to tell me that my code sucks. You want to try to pass along heartfelt, honest, I'm impressed with that. Hey, the code quality is really going up. In the last 2 months, we're noticing a lot fewer defects. Good job, everybody.
Now let's talk about the best practices.
And before we talk about best practices, I'm going to tell you that there is no such thing as a best practice. There's two terms in testing that I despise. And that's worse than hate. Hate is a strong word, and I despise best practices, and I despise quality assurance, QA. And people say, "Oh, I'm not QA, I'm not quality assurance, I'm a question asker." If you call yourself a QA, everyone thinks you're a quality assurance person. Let's just call you a tester, because what are you doing? You're testing. Are you assuring quality? I can spend 3 years testing a product, and the only thing I can assure you of is that there's a bug in there that I haven't found. So I can be incomplete assurance. I can assure you that I'm incomplete, but I can't assure quality. It's a stupid term. It's based on production line manufacturing terminology that does not apply to software. It's a term that I really wish would just go and die. Just call ourselves testers. If you want to be fancy, I don't know, call yourself a test engineer, although in Canada you can't use the term engineer unless you're an engineering graduate. So you got to be careful about that if you're in Canada. But just tester, there's nothing wrong with the term tester. And manual testing is another thing. Oh, did you manually code that? I manually tested this. You just tested it. Testing is an exploration and a learning. You can't do a manual portion of that. And yes, anyway, it doesn't matter. Best practices don't exist. What I do that works well for me is a good practice in my context. I have never, in at least 10 to 15 customers where I've made up test reports, I've never made up the same test report. They're all slightly different, because there is not a best practice for test reporting. There is not something that's always going to be good. But the term best practice, it's a good practice, or a good practice in certain contexts. So let's all, everybody listening, stop using the term best practice and stop using the term quality assurance. I actually got my entire team's name changed when I worked at Metadata. Everybody was QA when I started, and they were all testers. Intermediate tester engineer by the time we were done. Anyway, good practices of test reporting. Stop using metrics.
It's also important to question the words you use automatically, because they have a strong meaning behind it.
It does, and it's a bad meaning. And the other reason I don't like best practice is best is by definition, there's nothing better than it. My practices might be good. They're not best. They're good for me, but if you follow exactly what I've done, they might be horrible for you. I don't know. I would need to talk to your stakeholders. What are they looking for? What differences do they want in the test report to what they were given? And that's something that when I do test reporting, I ask that. I say, here's my first sample test report. Let me know what you like and what you don't like, and we can talk about how I can change it so that it fits your needs better. That's a good feedback loop to get into. You don't want to be saying, here's the test report. If you don't like it, well, too bad. That's what you're getting. That's not going to help. So, cutting out metrics. And the one thing a lot of people say, well, you need to give the metrics. And I've worked at companies that demand that, oh no, we need those we need to know how many tests you executed and what the pass rate was. And going, it doesn't mean anything. It's literally a stupid piece of information. If you want, I can write down the number of breaths I took during the day while I wrote this test report. It's just as useful to know than how many tests I executed. But again, that would be sarcasm and condescending and probably not a good way to approach it. But cut back on the number of metrics and provide different information. So information that I do like to provide is a mind map that shows coverage. So I created something called a release coverage outline, and what that is it's sort of the highest levels of the product that's being tested. A lot of times it's just what's displayed if it's a visual product, so a web page or something. I will break it off into what you can actually see on the page and say, oh, there's a search functionality, so I'll have search functionality. There's an advanced search, so I put that there. There's a sorting, all of these things. So you can put those elements in to your mind map. And again, this is if you look up product coverage outline or release coverage outline, and you search for that, you'll likely get some good information online. Doing coverage reporting of an entire product using a product coverage outline, it gets big. The biggest product coverage outline I ever created was at a company called MXI in Ottawa, and it was I think it was 45 pages printed out that I had to cut and tape together. It was massive. It was like the size of a massive whiteboard, and I put it up on the guy who had hired me's wall, and I said, this is not going to be helpful for anybody. It's too big. It's too complicated. I can't report on this. There's just too much information. And it ended up being helpful because the VP came by and he said, what's this? And he goes, this is what the product has become. And the VP honestly had no idea that it had become that complicated. And the guy was given 2 more testers to help test it because of the visualization of the complexity. So that was cool. Anyway, so show coverage. I like doing it in a mind map. It's the most visual, easy to glance at. If you see anything that's red, you go, well, why wasn't that covered at all? If you see anything that's a darker green color, you'll probably think, well, that either had to be simple or you're lying. You can't cover it at a dark green level. But showing how much each of those pieces was covered gives the stakeholders a feeling of security, I guess, that, we've had problems with advanced search in the past, and now you showed that the you covered advanced search to a good enough level that we're pretty confident that most customers aren't going to have any issues there. Giving an executive summary, nothing more than a paragraph or 2 that sort of summarizes the whole situation in a couple of words. Listing the important bugs. Your definition of important bug is going to change based on your context. If you're finding hundreds of bugs, then you don't want to list all of them. In telecom, we would go weeks and find 1 or 2 bugs. So listing all of the bugs is what we did because we didn't have that many. But if you're in a much faster moving like retail, we had so many bugs that we had to just go through them with the product owner. They were aware of all of them, and we would list off the ones that we would want in the test report with working with the product owner. So having the list of test reports, not test reports, test defects. If you have a risk list, which I would recommend you do, having that in your test report would be beneficial. Let's see, what else do I put in my test reports? So when I do a mind map, I have a legend that describes the levels. I usually do 6 levels of coverage, no coverage at all, just a sanity check, which is 1 or 2 happy paths. The 3rd level up is a bit more than sanity, some basic known error paths, but primarily happy paths. Common cases is the next level. So you've done an increased variety of scenarios, more complex, more error paths. Then you get into the second last level, which is you're hitting some corner cases, data states, error coverage beyond common cases. And then the last one is deep cases. Essentially, you've tested everything you can think of. It's rare to get to the last level, and I like having a level that doesn't even make it onto your mind map so that the stakeholders are aware that there's more testing that could have been done. Bugs, issues. Oh yeah, if anybody had any questions or concerns that we asked and either got an answer to or didn't get an answer to, we can put that in the test report so that we can highlight just questions that still need answering. And that's pretty much it. Then I often have links to supporting material, which would be, maybe where we put our test reports if we track our testing in Jira or some other system. I like to do exploratory test sessions. So if you're using session-based test management, SBTM, where your reports are, put a link to that in it. But that's pretty much it. So an executive summary, the testing coverage, bugs and issues, questions and concerns, and risks and impacts.
Okay. And do you have a favorite tool you're using for creating those reports, or mind map?
PowerPoint. I create them in PowerPoint because there you can put in a picture of the mind map fairly easily, but also it's just people are used to seeing PowerPoint slides and just quickly skimming them, and it also forces me to keep the information as a small amount, like a summary, just the highlights. And obviously, if anybody, when I'm presenting the test report, if people have questions, I'll answer the questions. And if they have questions and they say, I want that in the test report, I'll add it to the test report. That's fine.
Okay. And how often do you provide those reports?
That totally depends on what the stakeholders are looking for. At Saxoff 5th, we provided it at the end of the release only once. So we had, I don't know, I think we did releases every 2 or 3 weeks at Sax. So we just have a report come out at the end. So it could be reviewed the day before the go, no go, or we'd give it to them the day before the go, no go decision of the next release. In telecom, our release cycle, now granted this was 13 years ago, I don't know what it is now, but our release cycle was months long. I would provide a couple of interim reports, but for the most part, probably a report a month just to get a feeling as to how we were going. You could do daily reports. I was doing daily reports on that data lake issue because we kept just pushing it. And so one of the big things from the data lake issue was we were told that, we don't want to, we're going to be shipping soon. This was after the guy had been fired. We had a new deadline and we were still having issues, and we have to ship. There's no way we can't ship, the VP was saying. And then we showed a mind map. His team dumped 10,000 lines of code 3 days before we were supposed to ship. And yeah, I went to him. I said, "What do you do? You just dumped 10,000 lines of code. We have to test a lot. We can't just say, oh, it was a small update. It's 10,000 lines of code." So we gave a test report that our mind map was pretty much all red. It was all the no coverage and a little bit of sanity checking in it. And we said, here's our test report. And he was convinced that we were shipping on Friday. And the VP of product management looked at it and said, no, you're not shipping this. She wasn't about to sign off on it, which was the right decision in my mind. And yes, we did find a critical bug in our extra testing. So it was good.
Okay, so thank you. It was nice to learn from some good practices from you. Now we're gonna go to the last section of this interview. We're gonna talk about how we can get better at this exercise.
So most testers that I've worked with don't provide test reports. They rely on their manager or test lead to generate the test reports, and they just do their testing and update whatever test tracking software they're using, whether it's an Excel spreadsheet or TestRail or Jira. Within Jira, there's RTM and there's X-ray, which can be used. All of these things can be used. Most of them track scripted testing, which is horrible. I know Q-Test, you can track exploratory testing, but Q-Test, when it was owned by the original company, it was a lot more receptive to exploratory testing than it is now that it's owned by a different company. But anyway, a lot of testers don't even try test reporting. So I'd recommend just create a mind map of the product, maybe color code it, come up with a test report that your stakeholders, maybe your product owner, if you're just on a small agile team, just create a test report for the epic that you're working on. I wouldn't ever really recommend making a test report for like assuming people are in an agile type environment where they're doing stories that are part of an epic, which are then part of a feature. I would not a feature, yeah, a feature and then that feature becomes part of a release. I wouldn't do test reporting at anything below an epic. It's a lot of work, and to do it's not really a lot of work. I would say a good test report would take me between an hour and 2 hours to generate, including the mind map. I would also recommend not just continuously using the same mind map over and over again. They shouldn't take too long to make, like less than an hour or two. So every so often, like every month or two, just start from scratch. You'll find they get better and better the more practice you do and the more you make. But just start trying it, adding information, create a mind map, and color code it, and just start with that and show it to your team and say, this is how much I tested this epic. And like a good sort of rule of thumb is to go out maybe 3 levels. So as an example, if I have search and advanced search, that would be 1 level. And then under search, I can search for, autocomplete in the search, or accuracy, or searching for things that don't exist. And if it's supposed to come up with suggestions, have those as sort of the next level down. Under advanced search, you might go to different things that you can do. But typically in a release coverage outline, 2, maybe 3 levels down is the most you want to go. Otherwise, it just gets too busy. And again, if you want some examples, you can probably find some online. But just start providing extra information and see how that's received. That's what I would do.
Okay. And do you have resources to recommend, like books, blogs, influencer?
Yeah, I really am not a good blog person. I think the last blog on my testing thoughts webpage went up over 6 years ago. I'm really bad at blogging. The book that I've already mentioned, Taking Testing Seriously, it is by far the best book ever written on software testing, in my opinion. And that's not just because I wrote chapter 9. It's a huge amount of thought and effort went into this book, and it is an invaluable repository of testing information. It is almost impossible to read it and not be a better tester after you've gotten to the end. But unlike Lessons Learned in Software Testing by Kim Kainer, James Bach, and Brett Petticord, which is a much more light read. It's a bunch of little questions and then answers to those questions. It's an excellent book, but it's 25, 26 years old. There's obviously no mention of AI in that book, and limited information on automation. Taking Testing Seriously has chapters on AI and automation, so it's a lot more modern, but it's a deep read. It's not something you can skim and say, I got everything I needed. It's something that you'll need to sit down and read and reread. but it's also something that will make you a better tester. Another book I recommend is Charting the Course, Coming Up with Great Test Ideas Just in Time. That's by Robert Saborin, Sabourin. That's an excellent book as well.
Okay. Can you also talk about the courses you're giving? For example, the one at RST, if that can help also.
So rapid software testing, it's actually a collection of different courses. There's RSTE, which is Rapid Software Testing Explained. They are in-person courses. That's the one I teach the most. It's an in-person course, 3 days. James Bach does teach an online version, which I think is spread out over 5 days because of time zones and everything. You can't sort of focus on it. But there's also RSTA, which is Rapid Software Testing Applied, where you go through and I think it's more beneficial to take an RSTE before you take RSTA, but the RSTA is you actually use rapid software testing approaches to test and report on the testing you've done on a software project. There's also a rapid software testing on course on artificial intelligence, one for managers, and another one on automation. So those courses, there's 5 instructors, James Bach and Michael Bolton, who are the primary authors of Taking Testing Seriously. They're the co-inventors of the rapid software testing course. I was the 3rd instructor of RST, and then Hybe Schutz in the Netherlands is the 4th instructor, and then a guy named Griffin Jones in Rochester, New York is the 5th instructor.
Okay. So thank you. To conclude this interview, do you have any final advice you would like to share?
Just do things as a tester that artificial intelligence can't do. So think critically, ask questions, create models, provide value. Don't accept the drivel and the crap that comes out of AI tools as good testing. It's not. And it might one day be better, but right now, I have yet to see anything that comes out of tools. The biggest thing that has not changed in the 25, 30 years that I've been doing testing is vendors over promise and oversell whatever it is they're selling, whether it's outsourcing or automate everything or AI will replace your testers. They're all just marketing, and it's mostly false marketing. And by the time people figure it out, millions have been lost, lots of people get laid off, and then it's bad things end up happening. It baffles me that executives continue to drink the Kool-Aid being served up by vendors as the solution to their problems, when with even a little bit of scratching, the varnish comes off the promise pretty quickly. So be what AI can't and continue to provide value, and you should be fine. And if all of us did that, we would be knocking off these lies and false promises better than we are right now.
Okay, I agree. So thank you, Paul, for your time. It was a pleasure talking to you, and it was great to have all this knowledge, insights. So I've learned a lot today. So thank you for that.
My pleasure. Thanks for having me.
Yeah, no worries. For anyone curious, I will share your LinkedIn page so people can connect with you. I will share the website testingthoughts.com, your consulting company. And we'll also share the link for people to check out the course from RST page, and also a couple of videos so you can talk in details about test reporting and have some examples. So, yeah, thank you. So this concludes today's episode on how to test this. I hope you found this episode valuable. If you did, share it with your colleagues and stay tuned for upcoming episodes. We will continue to learn from experts about their favorite testing tools and tips to become better software testers. My name is Mamadou, and this was How to Test This. Thank you and see you next time.